This video looks at angular velocity. When we have an initial velocity that's going up at an angle, it's important to note that that is actually made up of two parts. There's two components to angular velocity. One component is a horizontal velocity. The other component is a vertical velocity. The reason that's important is because if we're going to write a set of parametric equations that models the motion, let's say this is a ball that's kicked off the ground, we might write a horizontal rule where x would be the distance it's traveling horizontally, and a y rule, which is the distance off the ground vertically. So if this is horizontal distance, this is vertical distance off the ground, then we need those components. We need to know that horizontal velocity. I'm going to use the symbolic notation velocity sub x, so that's going to be our horizontal velocity, and then our vertical velocity here. So even though there's not a physical triangle in the situation, this initial velocity, since it's going up at an angle, we can sort of visualize a triangle here that's representing, or the legs are representing those pieces of the velocity, that horizontal piece and that vertical piece. So if we want to find that vertical component to that diagonal velocity, one of the things we talked about was using the information we know from circular trigonometry first semester. If we have a point that started at standard position and it rotated 76 degrees, then the sine value would tell us about the height. We can see how that would relate to this vertical velocity. So the sine value of 76 degrees is 0.97. Now that would be the height on the unit circle. Our unit circle has a hypotenuse of 1. This angle is 76 degrees. So if instead we think about having a similar triangle, 76 degrees here, but that hypotenuse, instead of it being 1, if it's 25, we can see our scale factor for the similar triangles would be just to multiply by 25 here. So if I take this height on the unit circle, 0.97, and I multiply it by 25, then that ends up being 24.26. This would be that initial vertical velocity. So again, there's not a physical triangle, physical right triangle in the situation, but these pieces to these right triangles represent velocities for the situation. If I want to find the initial horizontal velocity, then I could think about the cosine of 76 on the unit circle. So the cosine of 76 is equal to 0.24. Again, unit circle, that radius is 1, and so this hypotenuse here is 1. Scale factor is still 25, and so if I take 0.24 and I multiply it by 25, I get 6.05. This would be the initial horizontal velocity. Okay. If I want to write a horizontal distance rule, then I would use this horizontal velocity to do that. If I want to write a height rule that talks about that vertical distance off the ground, I would have to use this initial vertical velocity within that rule.